Your EQ, how do you interpret algebraic expressions in the terms of their context? All right, so this one is only 7 slides. And so we're going to look at some of the vocabulary first. Hold on, let me just, there's a couple questions on here. All right, so an expression is a mathematical phrase that contains operations, numbers, and or variables. A numerical expression contains only numbers. An algebraic expression contains numbers and at least one variable. So when we have an equation like we were looking at yesterday, that is a mathematical sentence with an expression on the left-hand side and an expression on the right-hand side. And those expressions can be numerical, they could be algebraic. All right. Algebraic expressions are numerical expressions, but they also, I don't know if I should say it that way, because this says contains only numbers. So numerical expressions contain only numbers, and then algebraic expressions contain a combination of numbers and at least one variable. Now, the pieces that are being added together, the parts of the expression that are added together are the terms. And we looked at a picture yesterday in the lesson where we saw that. And then your coefficient is the numerical factor of a variable term. So if you have a term like 4x, 4 is the coefficient. It means that 4 is being multiplied by x. All right, and so this is our modeling expressions in context. This table shows some words, phrases associated with the 4 basic arithmetic operations. We have addition, subtraction, multiplication, division. So these are like keywords that if you see in a word problem, they're telling you like, hey, that's what you need to do right there. And we saw that yesterday too with the ostrich and the kiwi problem. Okay, there's some keywords in there that we turned into mathematical operations. And so these words and phrases can help you translate a real world situation into an algebraic expression. So this is a really good thing to reference when you are working with a word problem and you're trying to figure out, you know, what is it asking you to do? So these are words that mean addition, sum of, added to, plus, more than, increased by, total, altogether, and. Those all mean that you're adding. And then we have some examples over here of something you might see. Subtraction, less than, minus, subtracted from, the difference of, take away, taken from, reduced by. Those all mean that you're using subtraction. And you also have some examples here of what that might look like. So 2 less than a number is n minus 2. The difference of a number and 2 is n minus 2. Notice that when you do subtraction, the order is really important because the order that you subtract will depend on if you get a positive answer or a negative answer, maybe. So when you see less than, that word than, that shows up. This is also true with more than. It's the two things that you're comparing, they actually switch the order. So 2 less than a number means that I have to put the number first, and then the minus sign, and then the 2. Multiplication, times, multiplied by, the product of, percent of, the product of 6/10 in a number, 60% of a number, 6/10 n. Okay, these all mean the same thing. Those are all exactly the same thing. Divided by, for division, division of, quotient of, divided into, ratio of, the quotient of a number and 5, a number divided by 5. And again, so with division, that's also super important about your order. You don't have those commutativity rules with subtraction and division like you have with addition and multiplication. When you're adding two things or multiplying two numbers together, it doesn't matter the order, you're going to get the same answer. But that is not true with subtraction and division. The order is very, very important. So you have to be careful with your order on subtraction and division. All right, so we're going to look at an example, and then I'm going to have you guys help me out on this second example. We're going to write an algebraic expression to model the given context. Give your answer in simplest form. So the example that's already worked out is A, and it's on the left. The price of an item plus 6% sales tax. So the price of an item is our unknown. And then plus means to use addition. And 6% sales tax is the thing that we're adding. And then we have to take those three things and switch them into mathematical symbols and numbers that we can write an expression with. So if you have an unknown, that's where you use a variable. And the variable you choose to use, it doesn't really matter. In this case, you're using P because it's representing an unknown price. So it's a logical connection. But it could really be any letter you want. So P plus, and then 6% sales tax. So when you do sales tax, you have to understand that that 6% is of the sell price. So 6% of the sell price, of means to multiply. So how do you multiply 6% of our variable P? Well, you have to change 6% into a decimal. You can also think of it as like per 100. 6%, 6 per 100, 6 hundredths. And that's the number that you see there. 0.06 is 6 hundredths. So you can literally think of percent as per 100, and that'll help you convert it into a number that you can use in calculations. And so you just put that stuff all squished together. So the algebraic expression is P plus 6 hundredths times P. And those happen to be like terms because they both have the same variable P. So when you add like terms, you take the coefficients of your like terms and you add those numbers together. In front of the P, there's an invisible 1. It's the coefficient. Even though you don't see it, there's an invisible 1 there because there's 1 P sitting there. So 1 P plus 6 hundredths P is the same as 1 and 6 hundredths P. All right, we're going to do one of these now. Part B, the price of a car plus 8 5/10 sales tax. So we are taking the price of a car plus, okay, just like in the last example, that means we're going to add, and then we have 8 5/10 sales tax. So I have to figure out what's this next line going to look like. And that's what you guys are going to be doing on the Pear Deck slide. All right, so this is an opportunity now for you to click on the Pear Deck slide, and you're going to type out for me, what are we adding? What's in the blank plus what's in the next blank? And you can use the example to the left to help you kind of figure it out. I'll give you guys a couple minutes to write something down. I'm looking at your answers right now. Pretty good. I see some things coming up that make sense. Don't be afraid to type something in, even if you're wrong, okay? By you showing me what it is that you understand or don't understand, that tells me what to kind of review a little bit more. I have 6 of 25 responses, so I do need you guys to start typing something, even if you're not really sure what to type. I need you to participate. Okay, I'm going to show some of the responses that I'm getting from you guys. I only have 10 so far. I wish I would have more of you participate. So 1p plus 6p. 1p definitely makes sense here because there is a p. You could put 1p or just p. They're both exactly the same. And then this wouldn't be 6p for this one, okay? Over here, we're using a different percentage, 8 5/10%. How do I take that number and turn it into a decimal? So they turned it into a decimal by dropping the percentage sign. That's part of it, but you also have to think of it as being over 100. So you do have to move your decimal point. So here we see that we've moved it one time. Okay, but that is not quite enough yet because 0 and 85/100ths, this is the same as 85%. And we don't want 85%, we want 8 5/10%. So we have to move the decimal one more time and get an extra 0 in between the 0 and between the decimal and the 8. Oh, perfect, look at this. 0.085. This is the correct conversion of 8 5/10%, but it is missing one thing. All right, because the percent is of the price. So it's missing one little thing. This is good. They're typing. It's missing one little thing. Let's see, are they going to figure out the thing that's missing? They stop typing. We're missing our variable. Okay, so let me go ahead and show you. P plus 0.085 P. So the way you would read that decimal is 85 thousandths, and that's how you convert 8 5/10% into a decimal that you can do calculations with. So you're essentially thinking of it as per 100. So if you think of it as a fraction, 8.5 divided by 100, or dividing by 100 means you move your decimal point 2 times to the left. All right, so then they're taking this and adding it together. The last thing that I want you guys to do is to simplify that last expression. P plus 85 thousandths P. Those are two like terms. Can you add those two like terms together so we simplify our expression down to a single term? Okay, because right now we have two terms. We have two like terms that are being added together, but I want to simplify it down to a single term. And there's a couple questions in the chat. When are these notes due? I'm not going to collect your notes because you taking good notes and understanding what we're doing is directly reflected in how you perform on assignments and tests. That's different than middle school. Is this going to be on Google Classroom? The video that I'm making right now, yes. Okay. After our class, I'll download it, add it to YouTube, and put the link in our week at a glance, so that way you can go back and watch it again. And pause it. So like the nice thing about it is you can go back through, watch the video, pause it here, you know, oh, here's all these keywords that mean add, subtract, multiply, divide. Maybe your notes are totally digital. Maybe you just want to do a screenshot. of something and create a Google document and make that your notes. It's up to you. I don't mind how you choose to take your notes. Whatever is going to help you learn the concepts best, that's what you should do. Oh, good. I'm seeing some correct answers. So I have 7 responses so far. And we're going to go ahead and go forward because we do have about 10 minutes left in class, and I do want us to have time to do the last assignment. So here's the correct answer, last slide. If I combine the like terms of P or 1P plus 85 thousandths P, you add the coefficients together. 1 plus 85 thousandths is 1 and 85 thousandths. And then you keep your variable P. All right, that's it. That is the end of this lesson.